coordinate reference system. The first step is to import the DEM. Go to GIS, press Esri ASCII grid, select your data, press import. Step 2, go to GIS again, press import georeferenced raster, select your geological map, and now most importantly change the mode to base map on mesh. As object you need to select the DEM you imported in step 1. It is wise to verify that the data you imported are positioned correctly. Select the point where you have the X and Y coordinates and do the following 2 procedures. Step 1, go into top view by pressing numpad 7 or go into view, viewport, top. Step 2, go to the right side of your screen, press N, press View, Geoscene and press then Geocoordinates. Move your cursor to the point you want to check and read the coordinates on the top left of your screen. Next, let's display high-resolution photos in 3D that can serve to compile your geological observations and to construct detailed outcrop geological map in 3D. The data you need are a DEM in ASCII grid format and a georeferenced raster file holding the orthophoto compilation. Step 1, go to GIS, import the DEM. This time I select the DEM with a 0.5 spatial resolution. Step 2, go to GIS again, press import georeferenced raster, select your orthophoto dataset and set the mode to base map on mesh. As object you need to select the DEM you imported in step 1. If you want to view a very large digital terrain, there is a quick hit option available to bring Google Earth's terrain data into blended GIS directly. How to do it? You could follow the link given below, but be aware conversion into your local coordinate reference system will be a challenge. In the next tutorial I will show you how I prepare 3D geological maps and 2D cross-sections. Important items to do true 3D structural reconstruction.